Hello, Math Ease. This is going to be a video on power laws. Power laws. I will try to do this as good as I did yesterday, but we will see. So first thing is that you have a study sheet with 8 points for exponent laws or power laws. So we're going to just blast through them all. That way you have my way of doing it, and hopefully it matches what you're doing, and you can do the work that you need to do. Very first law, it is the zero exponent. That's not going to work. Exponent law. So remember, this is a really interesting one because if we're going to use 10 as our demonstration. Okay, so if I have 10 to the power of 1 to the 2 to the 3, 10 to the power of 1 is 10. 10 to the power of 2 is 100. That's 10 times 10. 10 to the power of 3, well, that's going to be 1,000. So if you look here, whatever my exponent is, that also equates to how many zeros I have. Now, I like doing it this way because often when you are learning something new, it's nice to have a basis for it. So with 10, if 10 to the power of 0, if the exponent tells me how many zeros I have, 10 to the power of 0 is going to be 1. So as this number gets higher, the number of 0 gets higher. Now, there's a long proof as to why anything to the power of 0 is 1. For this one, just memorize it. I can show you in class. So 342 to the power of 0, guess what? That equals 1. Mr. Paul to the power of 0, 1. So if anyone does this, like that, I'm number 1, I'm number 1. That's because 4 to the power of 0 would be 1. There you go, you can geek out on that one. There's the first law. Law number 2, exponent of 1. So whenever I have 5 to the 1, 6 to the 1, 7 to the 1, 130 million to the power of 1. When we look at this, what does this actually mean? An exponent tells me how many times I multiply my base. So if I'm multiplying my base once, that's just the number. So anything to the power of 1 is going to be that number. Mr. Paul to the power of 1, that's just 1 Mr. Paul. Anything more is scary, and I know you think that too. The next thing is the negative exponent law. Negative exponents are super cool. If I have 3 to the power of negative 4, similar to everything we do in integers, sometimes if we just look at the number, things make a little more sense. So let's take a look at 3 to the power of 4. Well, what is that? That's 3 times 3 times 3 times 3. Why is there 4 of them? Because that's how many the exponent tells me. If we have a negative exponent, this is the reciprocal. Remember, negative is the opposite of positive. So what we actually end up doing is that we end up putting this number as a fraction. So when I write it as a fraction, you'll notice that it is not negative anymore, because that's what this negative means. Okay? Here's something I didn't show you in class. Here's something that you can think about. If 3 to the negative 4 gives me 1 over 3 to the power of 4, these things are the same. That equal sign means they're the same. They're two different ways to write the same thing. What would 1 over 3 to the negative 4 be? Now this is purely theory. If you don't understand this, don't stress. But this means that it is the reciprocal. So this means that this is going to be the equivalent of 3 to the power of 4. Because this would mean that it has to go to the other side of the fraction. Okay? So anytime you have a negative exponent, you can write it in two ways. 3 to the negative 4 is the same as 1 over 3 to the positive 4. These two are the same. Awesome. My hand's going to get absolutely destroyed if I keep doing that. All right, that's the first 3 laws. Now remember, when you're reviewing your notes, you need to study these and think through them. Don't just be happy with kind of basic understanding. Memorize this stuff. It's not too hard. Number 4. This is integers and powers. The big thing here is that if I have, what? Let's go 3 to the, sorry, I wrote that improperly. If I have 3 to the 4, and then I multiply that by 3 to the negative 6. As you're going to see in a couple of things, if I have 4 and negative 6, when I do this, I'm adding negative 6, like so. See what I've got? I've got an integer problem. So please keep your integer notes handy. You're going to need them all the time. This one here, bigger team wins. It's bigger by 2. This is going to be negative 2. So this whole thing would be 3 to the negative 2. Number 5. Number 5 is in this spot for a very specific reason. Number 5 is different bases. So everything in our exponent laws, it deals with the same base. A base is the bottom number. It's the big number that we multiply by itself. 5 times 5 times 5 times 5. 5 is my base. This is not. So when I have different bases, let's say I have 5 squared times 2 squared divided by 3 squared, there is no shortcut. This is the first unit we always do. Order of operations, brackets, exponents, division, multiplication, that's occurred from left to right, addition, subtraction, that's occurred from left to right. I don't know if that's left or right, doesn't really matter. So here I actually have to do 25 times 4 divided by 9. You do it the long way. You know you will do exponents laws when the base is all the same. The questions look quite silly, but that's how you know when to use your laws. Number 5, 6. Oh, isn't that interesting? Look at your notes really carefully. There's 2 number 5s. So there's actually 9 points. No, none of you got that. That's really funny. That makes me laugh. Okay, so number 6, or the second 5, is the power law. Okay, so power laws are laws that are based on the same base. So if I have this times that times this, there's a way to simplify that. These only work for multiply and divide. If you ever have an addition, guess what? No shortcut. You've got to go the long way. You've got to find out what 5 to the 4 is, what 5 to the 3, and you add those together. So grade 9s, that will be a big trick on the PATs. The power laws only work for multiply and divide. Okay? Now let's get right into the laws. Finally, this one says number 6. It should be 7 on your thing, but product law. Product law. I write it so you see it. What is this the answer to? The product is a multiplication question. When you have things that are multiplied, you are going to use the product law. Say that out loud to yourself. It's very important that you do that. The vocabulary is what makes this all work. So let's take a look at 3 to the power of 2 times 3 to the power of 4. So the other big thing that you need to keep in mind here is something called the cumulative law. Cumulative law. By now, this has to be memorized. Oh, you can't see that. Cumulative law. What this states is that, oh, now my camera's all messed up. Oh, well. What this states is that if I am adding or multiplying, so if I have, I'm writing where you can't see, if I have 3 plus 4 plus 6 plus 7, it doesn't matter what order I do that in. I'm going to get the same answer. Same thing if these are multiplied. I can multiply 6 by 7, 4 by 6. I'll end up with the same answer. It only works for multiply and add. Those are the only 2 that work for. So here, knowing the cumulative law, let's take a look. What is 3 squared? It's 3 times 3. Now, you see how that's already, I have 2 3's? If I multiply the next term, which is 3 times 3 times 3 times 3, it just becomes a giant long multiplication problem. How many do I have? 1, 2, 3, 4, 5, 6. There's 6. That's the same as here. This says multiply this twice, multiply it 4 times. The answer is going to be as follows. The product law states that if the same base has powers on it, I add the exponents together, which gives me 3 to the power of 6. That's the proof for it. Okay? Doesn't matter what else is going on. That's the law. Okay, so that's the product law. Number 7 on your sheet is the quotient law. Now, one of the things I talked about in class that I think is so important is this. Multiply gives me add the exponents. The multiplication is the exact same symbol as plus. That's a great way to remember that. If I'm in the product law, look at it. That turns into a plus if I rotate it. Those two are linked together in many different units. So in this one, you add the exponents together. Now, the quotient law, what do we know? Divide looks like this, right? It also looks like a fraction sign. But what sign do you see within that? That little line is a subtraction sign. So remember, multiply is the opposite of division. So if here, the math doesn't break these kind of laws. If we're multiplying and we add the exponents, when we divide, what do you think we're going to do? Say it out loud. No one can hear you. Well, even if they can, they'll just think you're a little crazy. But that's okay. Let's make this smaller so I don't have to write so many out. So 4 to the 4 divided by 4 squared. Well, let's branch it out again. I have 4 4s on the top. I divide by 2 4s on the bottom. Right? 4 divided by, that gives me 1, that gives me 1. What am I left with? I'm left with 2 4s. 4 times 4 is the same as 4 squared. So, when we do this, we are going to go 4, that's my base. I take my 2 exponents, 4 minus 2, because they cancel each other out. Right? 4 minus 2 is going to give me 4 to the power of 2. Notice, this one gets bigger because we're multiplying. Multiplication makes things bigger. This one makes it smaller because we're dividing. Okay? Those are the two main ones. Those are the two you have to know cold. Divide, we subtract. Okay? Don't make it complicated. That's all you need to know for those. Okay, so quotient law is the answer to a division problem. Quotient, the quotient. Just got to memorize those. Just like you have to remember automatopoeia or some of those other cool English terms. All right, last big one. Oh, by the way, before I go on, let's say we have 4 to the power of 3 divided by 4 to the power of 7. Well, we go 4, 3. Can you see that? Barely. Hold on. Yeah, there we go. 3 minus 7. Now, a lot of you are going to make big mistakes here. Okay? Because this is integers. 3 minus 7. This is a positive. Do I subtract negatives? No. I add. This is a positive. It becomes a negative. That gives me 3 plus negative 7 is going to give me negative 4. The answer to this is 4 to the negative 4. Think back. What does a negative exponent mean? Bum-ba-dum, 1 over 4 to the 4. Both of those answers are correct. That's what I mean about integers. They really come into play when you are doing this. Now, if you can figure out that if you take 7 away from 3, you have negative 4, good for you. If not, good for you. Do it however it works, but watch those negatives. Last one. 8 should be 9. Power of a power. Love this one. So we have 5 to the 4 to the 3. I'm going to make these smaller again so I don't have to write so much out. 5 to the 2 to the 3. Now if you know this, solve it. Do it in your head. Let's break this down though, because that's the thing that makes it different. 5 squared. Let's put that in a bracket. 5 times 5. See that? Hopefully you agree with that. I know that's right. Now, what does this one tell us? The power tells us how many times we multiply this unit. So when we get this, I'm going to go 5 times 5 times 5 times 5. It's different than when you multiply. Because now we're actually multiplying the entire unit. Count them up. 1, 2, 3, 4, 5, 6. I end up with 6. 5 to the 6. But is this not multiplication? So instead of memorizing these, you need to think about them. What does this bracket means this is a number that's made up of these two. And if I cube that, I need 3 of those sets. This is how I remember it. If you look carefully here, or not carefully, just look. You see how there's 2 exponents through a bracket? When there's 2 exponents through a bracket, it actually makes 1/2 of a certain kind of sign. If you cross it, now I have the total. So that's how I remember it. You make up your own stuff. 5, 2 times 3. We're multiplying now. Power of a power. You have to first identify that this is a power raised to another power. And then remember, we're making it, it's like a product. PP. The power of a power, find the product. Ooh, the 3 P's, that's brand new. PPP. Whatever works. 5 to the 6. That's the answer. Now I'm going to do one with a bunch of them all together, because that's what your homework becomes. Rep them. Let's go 5 squared times 5 to the 4. Oh, let's make it really fun. To the 4 divided by 5 to the 3. Don't freak out. Take a breath. How long is this video? 16. Is that 16? Oh, good. We're doing great for time. I'll be done in a couple of minutes here. First thing, I am going to do brackets first, because that's BEDMAS. Okay, brackets. By the way, if this was a plus, if that was a plus on there, could I do it? I could, but it would be a pain because I would have to calculate everything. These laws only work for multiplication and division. Those are the only 2 things it works for. So let's start. I'm going to start with the smallest unit first, just like order of ops. So this one, 5 squared, 5 to the 4. What law is it? Say it in your head. Well, it's a product law. The product law, we add. You can't see that. Product law, we add. So I'm going to go 2 plus 4. Okay? Now, I'm going to keep that in the brackets, square it, put it over 5 to the 3. Next. What is that? Well, that's going to be 5 to the 6. So now I get 5 to the 6 to the 4 over 5 to the 3. I'm doing this a really long way, by the way. You can do it much shorter. See this? Power of a power. Let's multiply that. So now I'm going to get 5 to the 6 times 4 because it crosses over a bracket, 2 exponents right next to each other. 6 times 4 is going to be 24. So I get 5 to the 24 divided by 5 to the 3. Quotient law. Why? Because they're divided by each other. Imagine 24 of those 5s multiplied. And then imagine 3 on the bottom. They cancel out. 24 minus 3 is going to give me 5 to the 21. There's my answer. Don't solve that. Leave it. None of these things should ever be solved. You leave them as the power. You're just trying to simplify all the way down. Next week, I will see if I can post how this applies to polynomials. But as a quick preview, I'll do one so you can kind of get your head around this. We have 2a, that's not an 8, ab squared times 3a plus 4c. Okay, we'll just do it nice and simple. Now, remember our cumulative law. Now you'll see we have plus here because this is now polynomials, but the laws still apply. I could also write this as 2 times a times b times b. See that? This is going to be 3 times a plus 4 times c. So I can't cross these, but all of these, this is essentially what this is saying. So let's distribute. Well, I have to multiply each one of these by each of these terms. And you're saying, but those aren't the same base. They're not the same base. I can't do it. I can't do it. Yeah, you can. Because watch. Distribution. I'm going to go numbers first. 2 times 3. That's going to give me 6. I've got A times A. How many A's are there now? How many A's total? That's A times A. How many B's if I multiply B's times this? Are there any other B's? I'm still left with 2 B's. So the A's, that becomes my base. We just split it up. 2 times 4, next term. 2 times 4 is 8. A times, well, there's only one, I still have that A, it doesn't disappear. So I get times A, times B, times B, times C. If I had a B in there, guess what? I'd have another B. I'd have 3 B's. So in essence, what you're doing is I get 6A squared B squared. You see how I added that A? And then here I get 8A B cubed C. That's really all there is to it. So I'll do a little more on that because you have to look at this. Okay, now I can't add these because they have they're not like terms. Back to algebra. You can only add like terms. Like terms have the exact same variable combination. All right, I hope that helped. Remember, multiply is the same as plus, same sign, right? You write it the same way. This is the product law. Divide has the negative sign in it. This is what you do to the exponents. And when we have power through a power, you can't see that now. Power through a power, I am going to multiply those together. Good luck, guys. Bring questions, and we will talk to you later.